Hey guys, welcome back to Data Products. In this video, we're going to be plotting ECDF plots, and these are estimators of the Cumulative Distribution Function. And so what that does is it's a way to plot kind of a histogram or a distribution, like a Gaussian distribution, and allow you to easily look and say, okay, what percentage of my measurement, say weight, is less than 50 kilograms, and then you can easily look at your graph and say, okay, 40% of my individuals are less than 50 kilograms, etc. It'll make more sense once we actually plot, and I can kind of show you. So without further ado, then let's go ahead and get into it. Okay, so first things first, let's open our studio. All right, let's clear out this jazz, All right, new, our markdown. Whoops, okay, I just untitled, but I can change it up here, ECDF. Let's get rid of all this stuff. Okay, first things first, now let's do an empirical cumulative distribution function. This reports any given number percentile of individuals that are above or below that threshold. Okay, so this will make more sense once we do it. So let's just kind of dive into the deep end. So first thing we're going to do is set seed. You don't have to do this. This makes it reproducible because kind of like the previous, we did an example before where we used, we did weights of males and females and we randomly selected them. We're going to create that data frame again for our ECDF plot. If you don't do this, then every time you run your script, your random distribution will be different. So, all right. So first, I'm gonna create a data frame here called wdata, and it's gonna be a data frame. And within that data frame, we're gonna have sex, and that's a factor where we create male or female and male, and then each of them we're going to create 200. Then for the weight, we're going to do a collection of normally distributed measurements, 200 normally measurements randomly taken from a normal distribution. That's what the rnorm function does. But we want the mean of our normal distribution to be 55 for females. And then the same thing, we're going to do rnorm 200, and then for males we'll make the average weight 58. And then that's it. So you should have the, factor, rep, we gotta have a comma in between these. Unexpected, too many of those. Okay, let's try it again. There we go. Okay, so you should have the exact same numbers as me because we set the seed for this random distribution. But if you don't, that's fine. It doesn't really matter. Now let's look at our data frames. So we'll put this into our code. So let's just do head, wdata, and we'll just look at the top 5 of that. So we run this, you see we have females, the weight, and then this is also just drawn off the rnorm. It's the same number. Oh no, this should be the males. Interesting. Or no, females. Let me look at this. Rep CF weight equals. I'm gonna try clearing this and running it again. Oh, it's weird. I don't know why it's adding that extra column, but it doesn't really matter for what we're doing, so I don't feel like finding out. All right, let's keep going. So now let's load our plotting package, and we're going to do library ggplot2 theme set theme classic, and you can pick any theme that you've done throughout this. You can do black and was it gray, black, dark, whatevs. All right, so we did this is the stuff we've done before. Make sure that's not capitalized. So library ggplot2, we do our theme set, and we say our theme is classic, and I'm going to put actually the legend on the bottom. Why not? Something different. Okay. Okay, so this is the part. Now let's create our ECDF plot. All right, so now we're getting into the new stuff. All this other stuff we've typed up before. All right, so ggplot, we're going to do wdata, and our aesthetic is going to be x equals weight. And we're going to do stat ECDF aesthetic color equals sex, line type equals sex. So that means we're going to have a different color for each line and a different line type, so like dashed versus solid, etc. Now we're going to do geom equals step, size equals 1.5, and scale color manual. So we're going to pick our colors for this. Values equals C, and I'm just going to pick 00 AFBB. You can pick whatever ones you want. Indian red we use a lot, light blue, forest green, or whatever. E7 E800. I think this is back to my mustard yellow that will never go away. And labs, which is labels. Y, we're going to do we'll just do weight. Let me get rid of that so you can actually see. And I think that's all we need. ggplot. I don't know why there was an I there. Okay. So, interesting. Why is my data so... Did I put the same numbers here? Let's do this as... I'm going to rerun this code because they're like very on top of each other. Now what did I... Okay, something is wrong with my male female age gender weight equals CR norm. 250. Oh, why is it? Oh, there we go. Okay, so what had happened, I'm gonna keep this in. I'm not gonna edit it out because that was somewhat quick, and I can show you what I did wrong. So I actually had an extra comma in here. So what it was saying is weight is our norm, and then didn't treat this as part of this collection because I had closed off the collection already. So I had to move these around. So that's why I had that extra column, and that's why I probably should have stopped and been like, something's amiss already, because I had 2 columns and they weren't supposed to be there. So yeah, so this is what's supposed to, the parentheses are on the correct spot. So the weight is a collection of these 2 R norms and not one R norm and then this random thing here. Okay, so now if I run it all again, there we go. That makes a lot more sense. It's not the exact same number over and over again. Okay, so what does this mean? What does this ECDF plot mean? So from this, what we can do is we can be like, okay, what percentage of females, which is our teal line here, are underneath the weight of 50 kilograms? So we would just look at this and we trace it up and we'd say about 60% are underneath 50 kilograms. What percentage of females are underneath 55 kilograms? Well, that's about 100%. For males, we would say, okay, what percentage of males are under 56? And we'd say like 2%. Or what percentage is under like 57? We could change our labels to display more here. But this is just kind of the ECDF tool is for estimating, right? It's not like you wouldn't use it to get exact numbers. You just get an idea of the distributions. So yeah, so that's it. And it would probably be better. So if I change this back, because I messed with this since so we'll do 55 and 58 real quick and put my distributions closer together. Because they're so far apart on that graph, that's kind of what made it more difficult. So now you can see if we did 56, you'd say, maybe 1% under 56 for males, 58, 60. So these distributions, we pushed them back closer to the average that they were. So that is it for ECDF plots. This went a little bit longer than I thought. 12 minutes is not that bad. Because I had to troubleshoot my own code, but that's part of R. Like if you're having issues where you're like, man, I spend a lot of time messing up, that happens to everybody. It happens to me all the time. If you have watched multiple of my videos, you see when those technical difficulties come up, that's because I cut out 20 minutes of me trying to figure out what is wrong with my code because I've made a typo here, or made a typo there, or forgot to put a line in, or put too many lines in. All this stuff happens. So the more and more you practice and just do the coding, the quicker you are to be able to pick out what you did wrong, and the same errors will come up over and over again, and you'll be like, okay, well, this looks familiar because I spent an hour trying to figure out why it was doing this before, and I remember what I did. So without getting too much into it, don't be discouraged. It's muscle memory. The more you practice, the better you're going to get at it. With that, I'm going to quit rambling again. Thanks for watching. If you're watching on YouTube, please hit subscribe, and we'll pass this knowledge on to everybody else. And more videos to come. I hope to see you in the next one.